This video, I'm going to prove this really nice fact that 1 to the 5th plus 2 to the 5th all the way up to 105th is divisible by 4. If you like proofs like this, subscribe to my channel. That's all we do here. But seriously, note that 2 to the 5th, which is 32, is congruent to 0 mod 4, because it's a multiple of 4. 32 minus 0, which is 32, that's definitely a multiple of 4. That's why 32 and 0 are congruent. Okay, now if you have any other even number, like 4 to the 5th, well, this is 2 to the 5th times something else. Coincidentally, 2 to the 5th. If you have 6 to the 5th, this is 2 to the 5th times something else. In fact, if you have 2n to the 5th, where n is an integer, this is 2 to the 5th times n to the 5th. It's always, this here is always a multiple of 4. Okay, so let's write that up. So 2n to the 5th is equal to 2 to the 5th times n to the 5th. Now, I'm allowed to multiply these two numbers by anything I like. Well, this tells me that this times n to the 5th, which is also known as 2n to the 5th, is congruent to 0 times n to the 5th mod 4. Well, what that tells us is that 2n to the 5th is congruent to this mod 4. But this is 0. What that tells me is that 2 to the 5th and 4 to the 5th and 6 to the 5th and 8 to the 5th and so on, all the way up to 100 to the 5th, those are 0 mod 4. Okay, so let's see my scratch work. I guess only the last line. So what we have here is 1 to the 5th plus 3 to the 5th plus 7 to the 5th all the way up to 99 to the 5th plus, oh, that was a 1, not a bracket, plus 2 to the 5th plus 4 to the 5th all the way up to 100 to the 5th mod n mod 4. Okay, well, this is 0 mod 4. Okay, so this is equal to, so 1 to the 5th plus 3 to the 5th all the way up to 99 to the 5th. Actually, it does equal, I apologize, is equal to this mod 4. But check this out. 1 to the 5th is 1 mod 4. Now, or I should say 1 is 1 mod 4, which implies that 1 to the 5th is congruent to 1 to the 5th mod 4, which is 1 mod 4. And 3 is congruent to -1 mod 4, So raising both sides to the 5th power, we get 3 to the 5th is congruent to negative 1 to the 5th mod 4, and negative 1 to the 5th is negative 1 mod 4. So 3 to the 5th is negative 1 mod 4. And 5, well, this is 1 mod 4. Well, that implies that 5 to the 5 is 1 to the 5 mod 4, which implies that 5 to the 5 is 1 mod 4. And 6, well, I meant to say 7. When you divide 7 by 4, the remainder is 3, which is negative 1 mod 4 as well. It's negative 1 mod 4. Raising both of these numbers to the same power is allowed. Mod 4. Well, negative 1 to the 5th is negative 1. So 7 to the 5th is negative 1 mod 4. And this pattern is going to keep happening. We're going to get 1 mod 4, and then negative 1 mod 4, and then 1 mod 4, and then negative 1 mod 4. The question is, where will it end? That is 99. Well, 4 goes into 100 evenly, and this is 1 less. So 99 is negative 1 mod 4. Raising both of these numbers to the 5th power, we get 99 to the 5th is congruent, while negative 1 to the 5th is negative 1 mod 4. So we start with positive 1, then negative 1, then positive 1, then negative 1, ... and we end with negative 1. We start with 1. One pairing ends with negative 1. That's 0. The next pairing is 0. The one before is going to be positive 1 mod 4. So we keep adding zeros, 1 and negative 1, an even number of times. We have 1 plus negative 1 plus 1 plus negative 1 ... plus 1 plus negative 1 mod 4, but that all adds up to 0 mod 4. So what this tells me is that this whole sum really does equal 0 mod 4. So 1 to the 5th plus 2 to the 5th all the way up to 100 to the 5th is congruent to 0 mod 4. That is, you divide this number by 4 and the remainder will be 0. If you like seeing mathematical proofs like this, try subscribing to my channel. That way you could watch my videos all the time. See you guys in the next video. Watch and learn.